Hi all, very good morning. Welcome to Chandan English YouTube channel. This is Joshna. In this session, I am going to discuss what is electricity, what are the types of electricity, how the electricity is generated, what are the applications of the electricity. In this session, I am going to explain each and everything related to electricity in detail. Okay, so each and every student from starting to end, don't even miss a single point. Before starting the session, once all of you click the like button and even share it to your friends who needs the classes in English medium. Okay, very good morning one and all. So in this class I am going to discuss about the concept electricity, and at the end of the session I am going to display the MCQs. If you listen properly to this session, you can easily answer to any type of MCQ. Okay. What do you mean by electricity actually? Okay, in our daily lives, so each and everything, so most of the everything depends on what? Electricity. Even like a laptop or our mobile, so each and everything depends on electricity. So we need to know how the electricity is generated, how many types of electricity are there, and what are the uses, applications of electricity. So what is resistor, what is transducer, what are conductors, what are insulators, what are semiconductors, we need to know. Okay, so in this particular session I am going to discuss each and everything. So what do you mean by electricity, students? Electricity is nothing but it is the flow of electric charge, primarily electrons, through a conductor. Okay, how the electricity is generated? The electricity is generated, okay, by the flow of electrons. That electrons may be, so that is not electrons, flow of charge. That charge may be either positive charge or negative charge. Positive charge are considered as proton and negative charge are considered as electrons. Okay, flow of charges through a particular, okay, through a particular cross section, that may be a conductor or anything. Okay, flow of charge through a particular conductor is considered as what, students? Electricity. In that purpose the electricity will be generated. Okay, so this is nothing but, so imagine this is a copper wire, and what are these, students? These are nothing but electrons. Okay, electrons are protons, that may be either positive charges or negative charges. Charges are of two types. Positive charge are considered as proton and negative charge are considered as electrons. Okay, if the flow of charges through a conducting wire, if a flow of charges through a conductor, that may be a copper wire, so what happens there? Electricity will be generated. In general, we have two types of electricities. Okay, what are the two types of electricity, students? Static electricity and next thing is current electricity. Static electricity and current electricity, and in this current electricity it has two more types: alternating current and DC, AC current, DC current. So what is this static electricity? For example, okay, if two dissimilar objects, okay, if two dissimilar objects are undergoing friction, so what happens there? Electricity is generated. If two dissimilar materials undergoing friction, so electricity is generated. Even we used to play in our childhood. Okay, a person is sitting in the chair and someone is beating with a towel towards him. So what happens, students? When we touch that person, electricity is generated. So what is happening there actually? Two dissimilar materials or two dissimilar objects are undergoing friction. So what is generated there? Electricity is generated there, and that type of electricity is known as what, students? Static electricity. Okay, when two dissimilar objects are undergoing friction, the electricity which is generated through that friction is considered as static electricity. Even I have explained you the example also. Actually, who has explained about this static electricity, students? William Gilbert. Okay, William Gilbert has explained about this static electricity. So by what he has introduced this static electricity means, so when we are using our comb, okay, when we are combing, okay, what is happening while we are combing? There will be a friction generated between our hairs and the comb, and when that comb is kept near the papers, what happens to that papers? That papers will be attached to that comb. Nothing but the static electricity is generated between the comb and our heads, and their electricity is generated, static electricity. Okay, who has invented, who has introduced this static electricity, students? William Gilbert. And the next thing is what? Next thing is current electricity. So current electricity is nothing but the thing which I am discussing now. Current electricity is nothing but flow of charge through a cross section or through a conductor, that may be a copper wire or anything. So most of the charges will be passed through copper wire itself. Okay, the wires which we are using for generating electricity is nothing but copper wires. So what is happening in the copper wire, students? The flow of charges takes place. That charges may be mostly electrons. That charges may be protons positively charged or electrons negatively charged. So mostly which of the charges will flow to that copper wire? Electrons, negative charge. Okay, that is the difference between static electricity and current electricity. What do you mean by current electricity? Just now I have told you, the flow of charges through a conductor or through a cross section is considered as a current electricity or electricity. And in this electricity we have two types of electricities. One is alternating current and one is direct current. What do you mean by direct current, students? Direct current is nothing but this is not dangerous to us. Okay, direct current is not danger to us. When comes to alternating current, okay, alternating current is dangerous when compared to direct current. So what is the example for this direct current? Example, batteries. Okay, the batteries consist of this direct current. Okay, and what do you mean by direct current? The direction of flow of electrons. The direction of flow of electrons in the direct current will be uniform. So remember this. What is the difference between direct current and alternating current, students? The flow of charges in the direct current will be uniform. That means they will maintain the same direction throughout the current passing. And when comes to alternating current, the flow of electrons direction will be differed. The flow of electrons direction will be differed, and that current is known as alternating current. Okay, which device is used to convert direct current to alternating current means resistor, and which device is used to convert AC to DC means inverter. Okay, remember, very important. So these are the basic concepts which everyone has to know. Okay, I think everybody understood what I said. So that is the introduction. Ma'am, voice is very low. Is it okay now? Please, any one of you confirm. Is it okay now? Wait a minute. Can you hear? Please, any one of you confirm. Yes. Is my voice audible? Yes. AC to DC rectifier and DC to AC. Okay, done. Okay. So now I am going to discuss in detail what is electricity, what are the types of electricity, what are the applications of electricity. Okay, what is electric energy, what is electric power, what is Ohm's law. In detail, I am going to explain each and everything. So from this electricity chapter, you can get 2 questions for sure. Okay, you can get 2 questions from this chapter. So each and every student listen properly. Okay, okay, done students. Let's enter into the class. Electricity is the flow of electric charges, particularly electrons through a conductor, creating an electric current that powers modern life. So mostly in our daily lives, so everything is running on what, students? Everything is running upon electricity. So we have to know what is happening in the electricity, how it is generating. So each and every student must have a little knowledge regarding that. Okay. So this is nothing but copper wire. Copper wire is nothing but it is a conducting material. Okay. So what is happening here, students? Flow of charges. So especially electrons. Flow of charges is taking place there. So indirectly what happening there? So electricity is generating, and that electricity we are using for many purposes. Okay. Next, imbalances between positive and negative charge like static. So just now I have told you now, what do you mean by static electricity? Two dissimilar objects, when two dissimilar objects are undergoing friction, So there generates a electricity. That electricity is considered as static electricity. Who has discussed about the static electricity? William Gilbert. And not only that, students, you know who is Benjamin Franklin. So what is Benjamin Franklin has explained about? Okay, when two clouds, hit together, so what happens? There appears a lightning. When two clouds hit together, there appears a lightning. And when the cloud hits the ground, so there appears a thunder. Okay, so this was explained by whom, students? By Benjamin Franklin. Even remember this topic also. Okay, next. So basic concept. What do you mean by charge, students? Just now I have told you. And what is the formula for current? What is the formula for current? Current is denoted by I. I is equal to charge by time. Okay, charge by time. That means the flow of charges. The flow of charges in a particular time. The flow of charges in a particular time is considered as current. Okay, current is denoted by I and the formula for current is Q by T. And what are the units? What is the unit for current, student? Ampere. Okay, and what is the unit for charge? Coulombs. So remember, each and everything is important. So charge, protons positive and electrons negative make up atoms. Imbalance create potential for movement. Okay, what do you mean by charge, students? Charge consists of positive charges and negative charges. Positive charges are nothing but protons and negative charges are nothing but neutrons. The flow of charges in a particular time is considered as what, students? Current or electricity. Voltage, the electrical pressure or potential difference that pushes electrons. For example, okay, for examples, if there is any disturbance, for the flow of charges, so what happens there? Potential difference takes place. Okay, when there is a disturbance between the flow of charges, when there appears a disturbance in the flow of charges, so there exists potential difference, and that potential difference, it is measured by voltmeter. Next, what do you mean by current? The rate of flow of electric charges. Just now we have discussed. What do you mean by resistance, students? Resistance is nothing but opposition to the flow of charges. When there is a disturbance for the flow of current, so that term is considered as resistance. Okay. Next, what do you mean by circuit? The path through which the current is flowing. The path through which the current is flowing in a closed manner, that is considered as circuit. Okay. Very good, very good. DC to AC inverter, AC to DC rectifier. Very good. So what are the application? Essential. So why do we use electric, students? For lightning purpose, for electronic appliances purpose, so for many purpose in industries. Okay, mostly in industries, which type of current we will use, students? AC. Not only in industries but also the current which we are using in our daily life, which type of current is that? AC current. Okay, what is the difference? I have explained you already. In direct current, the direction of current will be uniform. The direction of current will be uniform, and when it comes to alternating current, the direction of current will not be uniform. So that differs at each and every point. Next, they can be effectively converted from mechanical, thermal or chemical energy. For example, so take the cooler as example. So what happens, students? What is happening there? Electricity is converting into mechanical energy. Even the electricity converts one form of energy into another form. Best example is cooler. What is happening in the cooler? How the cooler is working? Okay, when we switch on the when we switch on the electric cooler, so what happens? The electricity is automatically converting into mechanical energy. What is happening there, students? Electrical energy is automatically converting into mechanical energy so that the coolers rotate. Okay? Yes. Next, electricity is sold by the kilowatt hour, a measure of energy consumption. So what is the unit of energy consumption in electricity? Kilowatt hour. Remember, very, very important. Okay? So, current is measured in, or electricity is measured in amperes. Okay? Current is denoted as I, and energy consumption is measured in kilowatt hours. Remember the difference. Next, types of current electricity. I have told you already. Generally, we have two types of electricity. One is static electricity, that was explained by William Gilbert, and the next thing is current electricity. And that current electricity are again classified into direct electricity and alternating electricity. Okay, there are two types of current electricity: direct current, alternating current. What do you mean by direct current, student? I have told you already, direction remains the same is known as direct current. In a current, if the direction remains the same, for the flow of charges, if the direction remains same, that type of current is considered as direct current. Okay, so what happens here actually, it is defined by the constant flow of electrons from a region of high electron density to a region of low electron density. So where we will use this direct current, students? It is used in many household appliances and the application that involves a battery. Example for the direct current is battery. Okay, what is the best example for direct current? Battery. So what is happening in this direct current, students? The flow of charges takes place in the same direction. If the flow of charges takes place in the same direction, that type of current is considered as direct current, and it is not harmful to us. Even if we keep the battery in our mouth, so there will be no harm to us. Okay, that is the difference between direct current and alternating current. Now, what is this alternating current, students? Alternating current, so it is a type of current electricity, so where the flow of charges takes place in a different directions. Okay, where the flow of charges takes place in different directions. The current electricity that is bidirectional and keeps changing the direction of the charge flow is known as alternating current. So why that bidirectional is caused by? That bidirectional is caused by sensorially varying current and voltage. So why that alternating current? Okay, what is happening in the alternating current, students? So for every time, at each and every point, the current and voltage are differing. At each and every point in the alternating current, the current and voltage are differing. For this purpose, okay, alternating current, the flow of charges are traveling in different directions, bidirectional. Okay, so what you have to remember, students? Direct current, the flow of charges takes place in the same direction, and in alternating current, the flow of charges takes place in different directions. Why? Because at each and every point, the current and voltage are differing. Okay, next. Next, Telangana High Court 2026, almost 859 vacancies have been released. I think everybody knows this. So, complete course is available on our Chandan Logics app. So, students who are appearing, so who is going to apply for this post, so they can purchase this course. Telangana SI Constable, so almost 14,000 vacancies are yet to be released. So, each and every students who are going to apply for that examination, you can purchase this course. RRB Group D complete course is also available on our Chandan Logics app. SSC GD special batch complete course is also available. SSC CGL special batch complete course is also available on our Chandan Logics app. RRB NTPC special batch complete course is also available. SSC exams complete course is also available on our Chandan Logics app. Railway exams complete course is also available. Bank exam complete course is also available. Bank SSC RRB combo course is also available on our Chandan Logics app. APPSC, TGPSC, SI Constable courses also available. UPSC CSAT complete course also available. So what do you mean by circuit? I have told you already, the path through which the current flows, is considered as circuit. So it must be closed loop. Okay. A circuit is a complete closed loop or path that allows electric current to flow typically from a power source like a battery through components like wires, switches, bulbs and back to the source. So what do you mean by circuit? So just now I have told you the current is passing from a source. So that may be a battery or anything. The current is passing from a source to the appliances. So what are those appliances like wires, switches, bulbs? So what is happening here? The current is traveling in a circuit mode. The current is traveling in a closed loop, and that closed loop is considered as what, friends? Circuit. Okay. Performing work as it travels, like lightening a bulb or powering a computer. For current to flow, the path must be continuous, a closed circuit. Any break stops the flow. Okay, what is happening here, students? So this is nothing but battery. So think this as a battery. So this is light bulb. Okay, so what is happening here? The current from this battery is passing to this electric bulb. So that what is happening here? The electric bulb close. So everything is happening in a closed loop. Everything is happening in a closed loop. The current from a source, it is applied to the object. So everything is happening in a closed loop, and that closed loop is considered as circuit. So if there is any break in this circuit, okay, if there is any break in this circuit, so what happens? There is no flow of current, and what happens? There is a break for that current. Okay, by this we can say that the circuit should be always continuous and closed loop. At that situation only the current will be flowed through that any object. Okay? Yes. Next, types of circuits. So I have explained just now what is circuit. Circuit is nothing but it is a continuous closed loop in which the electricity flows. Okay? And what are the types of circuits? Simple circuit, electronic circuit. What do you mean by simple circuit? Just now I have explained. The thing which I have explained just now is simple circuit. Simple circuit is nothing but it consists of a continuous closed loop. Okay? Next one is electronic circuit. More complex, including active components like transistors for advanced tasks like radios, computers. For example, I will explain what do you mean by simple circuit, what do you mean by electronic circuit. Simple circuit is nothing but a circuit from which the current is flowing from a source to the electric bulb. Okay, this is happening only in a single circle or single cycle. Now when comes to this electronic circuit, in order to pass the electricity from the source to the object, so many things are involved in this. So what are those many things? Like transistors for advanced taxes. For advanced taxes, for example, in radios and computers, what is involving in this electronic circuit, students? So many things like transistors, example. Okay, when comes to this simple circuit, there is nothing between the source and the object. Okay, there is nothing between the source and the object. And when comes to this electronic circuit, there exists some of the extra components, example transistors, for extra task to be done. Okay. Next, series circuit. Components are connected end to end in a single path. So we know very well about this series connection and parallel connection. For example, so you all know this is cell. Okay, you all know this is cell. Okay, the thing which is bigger and thinner is positive, and the things which is smaller and thicker is negative charge. Okay, and single thing is considered as what? Cell. The combination of this is considered as what, students? Battery. You all know. Okay. The combination of this is considered as what, students? This is considered as battery. Okay, if a negative charge is connected to the positive charge and that positive charge is connected to negative charge again, so if this is continuing, that particular thing is called as what? Battery. We all know very well. So if the thing is happening in the sequence model, that connection is known as what, student? Series connection. In series connection, the passage of current will be same. Remember, everybody knows this. Okay, what is happening in the series connection? The positive charge is connected to the negative charge, and the negative charge again it is connected to the positive charge. If this is happening in the sequence model, that type of connection is considered as what? Series connection. And what do you mean by parallel connection? Okay, so this is current actually. Okay, all the things are connected to like positive, and all the things are connected to negative. If one side all the appliances are connected to positive and other sides all the appliances are connected to negative, that type of connection is considered as parallel connection. In this parallel connection, voltage is same but the current is different. So know the difference, students. In series connection, current is same, voltage is different. When comes to parallel connection, voltage is same but the current is different. In series connection, if there is a damage at a single point, so the current will be stopped. But in parallel connection, even though the circuit is break at one connection, the current will be passed to the another connection. Okay? Yes, I think everybody knows this. Components are on separate branches allowing current to split and flow through multiple paths. For example, okay, so this is this is battery. You think this is battery, okay? So it is happening like this. This is positive and this is negative. Even though the current stops here, even though the current stops in one branch, the current will be flowing in other branch. That is the difference between series circuit and parallel connection. Next thing, electromotive force. So this is very, very important. What do you mean by electromotive force and what do you mean by voltage? Electromotive force, it is defined as EMF. It is the energy supplied by a source like a battery per unit charge. Nothing but, for example, I am taking a source. What is that source? Battery. I need to lighten the bulb. Okay, I need to lighten the bulb. So what is happening here? The energy from the battery is transferring to the bulb to glow. So this purpose, the transfer of energy, okay, the transfer of energy from the source to the object, and that energy is known as what, friends? Electromotive force. The energy is supplied from a battery to the object in order to generate electricity or in order to work that object, and that energy is considered as electromotive force. Did you understand what I said? Okay. The energy is supplied by a source like a battery per unit charge representing the maximum potential difference when no current flows. Okay, that is nothing but when no current flows. When no current flows, the maximum energy supplied from a battery to a object is considered as electromotive force. Next, while voltage is the potential difference measured between 2 points. For example, the current is flowing like this. The current is flowing like this. The potential difference, the difference between 2 points, when there is a disturbance in a flow of charge. Listen properly, students. The current is flowing in a manner. Okay. Suddenly there appears a disturbance. Suddenly there appears a disturbance. So what is the potential difference? The potential difference is nothing but the difference between the 2 points. So when it is not disturbed and when it is disturbed, the difference between the flow of charges between those 2 points is considered as potential difference. Okay. Next. Now what do you mean by this? What is the relationship between the voltage and EMF? Nothing but voltage is nothing but voltage is equal to EMF minus internal resistance. The disturbance which I have explained just now is considered as internal resistance. Internal resistance is nothing but disturbance, opposing of flow of charges. Okay, voltage, EMF is nothing but what, students? The energy supplied from a source to the object. The energy supplied from the source to the object when no current flows is considered as what, students? EMF. And what do you mean by voltage? If there exists a internal resistance, for the flow of charges, so there appears the difference between 2 points of charges is considered as what, students? Potential difference. And what is the relationship between voltage and EMF? Voltage is equal to EMF minus internal resistance. Okay. Next. So these both are measured in volts. Okay, both the potential difference and EMF, these both are measured in volts. Volts is nothing but joules per coulomb. Okay. Next. Very, very good morning, Basha. Next, Ohm's law. So we all know very well about this Ohm's law. So mostly from electricity concept, the question which is appearing repeatedly is from this Ohm's law only. What do you mean by Ohm's law? Ohm's law is nothing but In simple, V is equal to IR. V is nothing but voltage, I is nothing but current, and R is nothing but resistance. So in simple, voltage induced is always directly proportional to the current generated. Voltage induced is always directly proportional to the current generated, and that is considered as Ohm's law. V is equal to IR. Ohm's law describes the fundamental relationship in electric circuits. Voltage equals to current, resistance expressed as V is equal to IR, stating that current is directly proportional to the voltage and inversely proportional to the resistance. Okay, what do you mean by this, students? I is equal to V by R. What it is saying? Resistance is nothing but what, students? Resistance is nothing but it is opposing the flow of charges. Resistance is nothing but it is opposing the flow of charges or flow of electricity. By this we can say that current is always directly proportional to the voltage and inversely proportional to the resistance. From this equation we can write IV is equal to IR, and this is considered as Ohm's law. Okay, current is always directly proportional to the voltage and inversely proportional to the resistance. That means if the voltage is high, electricity generation will be high. If the resistance is high, electricity generation will be low. By this we can say current is always directly proportional to the voltage and inversely proportional to the resistance, and from this equation we will get V is equal to IR, and this is considered as Ohm's law. Okay? Yes. Next, what do you mean by electric power? Okay, electric power is nothing but the rate at which electric energy is transferred or converted, measured in watts. We all know power. Power, what is the unit for power, students? Watt. And now what do you mean by electric power? The rate at which electric energy is transferred or converted. The rate at which electric energy is transferred or converted. For example, just now I have told you, what do you mean by EMF, electromotive force? Nothing but the energy supplied from a source to an object. When no current force is considered as EMF, right? And that electric energy, the rate of electric energy which is converted or transferred is known as what, students? Electric power. So electric power is always measured in watts or joules per second. Okay, how you will get, students? Electric power P is equal to V into I. Very important formula. Electric power P is equal to V into I. Power, electric power is equal to voltage into current. Very important. Okay, electric power P is equal to voltage into power. What is the unit of electric current? Electric power, watts or joules per second. Okay, so mostly you will get units only. What is the unit of electric power, students? Watts or joules per second. And what is the formula? P, electric power is equal to voltage into current. Nothing but the rate of electric energy transferred or converted. The rate of electric energy transferred or transfer or converted is considered as electric power. Okay. So, and is fundamental for powering devices with AC alternating current being common for distribution. Next. So, this is one thing, students. For smaller quantities, electric energy units is watts. Remember, very important point. For smaller quantities, electric power unit is watts. For larger quantities, electric power units is kilowatts. Remember this. Okay, and megawatts for larger scales. Okay, note this point, students. For smaller units, electric power units is watts, and for larger quantities, electric power units is either it may be kilowatts or megawatts. Know the difference. Okay. Next. So daily at sharp 11. We are going to conduct general science session, not only physics but also chemistry and biology. So you can even check the classes which are already conducted. Okay. And what is the formula, students? Power is equal to voltage into current. So remember this formula. So in this, till now how many formulas we have discussed? I is equal to Q by T. Current is equal to charge by time. And one more thing, V is equal to IR. Okay, what is that? Ohm's law. And now we have discussed what is electric power. Electric power is nothing but the rate of electric energy, either it is measured or converted, and that is considered as electric power. P is equal to VI. And the next thing is electric energy. What do you mean by electric energy? The energy is the energy from moving electric charges through a conductor resulting from a potential difference. Okay, so I have told you that. So this is a copper wire. Okay, and the electrons are moving. The charge is nothing but negative electron. Electrons are moving in this copper wire. Now how the electrons are moving, students? For the flow of the electrons, that required a energy, right? For the flow of charges, that charges required a energy, and that energy is considered as electric energy. Electric energy is nothing but it is the energy required for the flow of charges in a conductor or a copper wire, and that energy is considered as electric energy, and it is vital for powering modern life. Okay, so and that electric energy, it may be converted either from heat energy to electric energy or electric energy to mechanical energy. So tell me, students, what is the formula for electric energy? So tell me, what is the formula for electric energy? And this electric energy, it is measured in joules or kilowatt hours. Okay, what is the unit of electric energy? Electric energy is measured in joules or kilowatt hours. So tell me the formula for electric energy. So this is the homework for you. Now you have to say me. What is the formula for electric energy? Each and every students who are in the live session. So tell me what is the formula for electric energy. I have told you the formula for electric power. Electric power is nothing but voltage into current. And what is the formula for electric energy? W. Nothing but work done. No Sunday holiday. Okay, tell me, students, what is the formula for electric energy? I have told you already the definition of electric energy, and even the unit of electric energy is either it may be measured in joules or kilowatts hour. So tell me the formula for electric energy. Come on, students. Power into time. Tell me the correct answer. What is the formula for work done by time? Okay, what do you mean by electric energy? Work done by time, or what? Voltage by time. Okay, done. Okay, electric energy, it is denoted by W, that is nothing but voltage by time. Done. W is equal to V by T. Very good. Next thing, heating effect. This is very, very important, students. So mostly, if you get problems from this particular electricity concept, so mostly they will ask this concept problems only. Heating effect, it is also known as Joule's heating. Okay, H is equal to I square RT. What is the formula, students? H is equal to I square RT. H is nothing but heat, I is nothing but current, R is nothing but resistance, T is nothing but T. So remember this formula. Even I have explained about this formula in physics problems. You can check that session also. Okay, in Chandan Law's main channel, I have explained physics problems concept. If you look at that particular session, you can get many problems, many formulas from physics. Okay, so H is equal to I square RT. It is nothing but heating effect or Joule's law of heating. So where we will apply this Joule's law of heating, students? The best example is water heater. So what is happening here, students? Here electric energy is converting into heat energy. What is happening in this Joule's law of heating? Electric energy is converting into heat energy. Perfect example is water heater. So what is happening here, students? So water heater, what is happening there? Electric energy. So when we switch on the electric heater, water heater, So automatically the water gets start boiling. So what is happening here? Electric energy is converting into heat energy, and that heat energy is letting the water to boil. Okay, and that is a perfect example for this heating effect or Joule's law of heating. Okay, and the formula for this is H is equal to I square RT. H is nothing but heat induced, I is nothing but current, R is nothing but resistance, and T is nothing but time. That means if heat energy is passed, the current induced will be doubled, even the resistance within a short period of time. Okay, so what do you mean by this formula, students? In my words I am explaining you. Okay, if the heat is passed to a object, if a heat is passed to a certain object, so what is happening to the object? The current is doubling, even though the resistance is passing in a certain time. Okay, for example, okay, I am explaining you the thing which I have understood. Okay, I am switching on the current. So does the water get start boiling in a seconds? No, it takes some time. For the water to be boiled, it takes some time. Okay, that means what it is considering, students, it is even considering the time and the resistance also, and that law is considered as heating effect or Joule's law of heating. The heating effect of electricity or Joule heating is when a conductor heats up as current flows, it is converting electric energy into heat energy. I have told you already in the beginning of this concept only, have told you perfect example. If you don't know this definition, just remember water heater. So what is happening in the water heater, students? Electric energy is converting into heat energy and the water gets start boiling. Okay, just remember that and remember the formula also. H is equal to I square RT. Okay, so this is the formula for this. H is equal to I square RT. I is nothing but current, R is nothing but resistance, T is nothing but time. Heat is equal to current into resistance into time. Okay, how the heat is generating? Heat is generating nothing but the product of current into resistance into time. As the time passes, the current flows even though there is a resistance. And what is happening here? Heat energy is converting into electric energy. Okay. So where we will use this terms? In toasters, in electric irons, in heaters, in fuses. So these are the some of the examples. Best example is in toasters also. In toasters, in electric heaters, and even rice cookers. So what happens in rice cookers? Electric energy is converting into heat energy and the rice gets boiled. Okay. Next, applications. So I have told you just now, in toasters, electric kettles, heaters and irons use elements with high resistance to produce heat. So what type of materials we will use for this electric heater, students? Iron. So which is having the high conductivity, we will use that type of materials only. Okay, in the materials where there is a possibility of high electricity passes, so we will choose that type of materials only for this electric heaters, toasters, etc. Next, so what are the safety devices? Fuse wise have high resistance and low melting points to melt and break a circuit. What do you mean by safety devices? The perfect example for safety devices is fuse. When there is a high voltage current is passing, okay, when there is a high voltage current is passing, so what happens there, students? So what is the safety device we will use there? Fuse. That fuse should be made up of a material which is having a very low melting point. Okay, that fuse must have a material which is having a very low melting point. So when there is a very high voltage is passing, what happens, students? The fuse gets heated up and the circuit will be breakdown. So there will be no passage of current. Okay, so which is the safety device we use in electricity? Fuse. And that fuse must be made up of a material which is having a very low melting point. If there is a high current passage, so what happens? That material, that copper wire will be break, so that there will be no passage of electricity. Okay. Next. So core electric components, and now we are going to discuss the core electric components. So what is that? What are those? Transducer, an electric device that converts energy from one form into another. So I have told, just now I have told you, okay, in Joule's law of heating, what is happening here? Heat energy is converting, sorry, electrical energy is converting into heat energy. For this conversion, we require a component for the conversion, and that component is considered as transducer. Okay, what is the function of this transducer, students? This transducer, it converts one form of energy into another form. For example, electrical energy is converting into heat energy in electric heater. Electrical energy is converting into mechanical energy in electric cooler. For this conversion, there requires a component, and that component is considered as transducer. Okay? And the next thing is input transducer. So these transducers consist of two types. One is input transducer and the next one is output transducer. Input transducer is nothing but sensor. It converts physical energy like sound, light or heat into an electric signal. This transducer again classified into input transducer and output transducer. The best example for input transducer is sensor. That is nothing but it is converting the physical signals into electrical signals. If the physical signals are converting into electric signals, that is a sensor. That is the best example for input transducer. And output transducer. What do you mean by output transducer? And the best example for this input transducer is a microphone. It is converting sound waves into electrical signals. What is this microphone is doing? It is converting sound waves into electric signals. Next thing, output transducer. And the best example for this output transducer is actuator. What it is doing, students? It is converting electric signals into physical actions, reverse. In input transducer, it is converting physical actions to electrical signals. So what is happening in output transducer, students? These output transducers, it is converting electrical signals into physical activities. Example, a loudspeaker. Okay. What is the input transducer example? Microphone. In microphone, the sound waves are converting into electrical signals. And in loudspeaker, what is happening? Electric signals are converted into physical activities like loudspeaker. Okay. Next, generator. You all know what this generator will do, students. It will convert mechanical energy into electrical energy. Okay, the device which converts mechanical energy into electrical energy. So when the generator is on, so there exists a sound, right? So what is happening here? The rotation is happening here. The mechanical energy is converting into electrical energy. It typically operates on the principle of electromagnetic induction, where a conductor moving through a magnetic field induces an electric current. So on which principle the generator works? On electromagnetic induction. So what is happening here? When a conductor is moving around a magnetic field, when a conductor is moving through a magnetic field, so there exists a electric energy. So what is happening here, students? Mechanical energy is converting into electrical energy, and that device is considered as generator. Generator works on which principle? Electromagnetic induction. What is happening in this electromagnetic induction? When a conductor is passing through a magnetic field, there exists a electricity. Next, inverter. Inverter is nothing but a power electronic device that converts DC to AC. So remember, students, DC to AC means inverter, AC to DC means rectifier. Know this difference. Okay? The device which converts alternating current to direct current is rectifier, and the device which converts direct current to alternating current is inverter. Okay? So mostly in all our homes, so we know what is inverter. So when the current gone or when the power is off, so directly we will switch on the inverter. So what is happening there? Actually direct current, the current which is stored in the battery, so that is converting into alternating current. Okay. Next, difference between total resistance and current parts. Okay, so now I am going to discuss about the difference between series connection and parallel connection. I have told you already, series connection is nothing but what, students? Okay, so when the cells are connected in a series, that is known as what? Series connection. In the series connection, the current will be same and the voltage will be different. If there is any break in a connection, so the current will be stopped. And when comes to this parallel connection, in parallel connection, the current is passing in two different branches. Okay, when there is a break in one branches, the current will flow to the other branch. Okay, that is the difference between series connection and parallel connection. In series connection, the total resistance will be equal to the resistance of all other cells. Okay, and in a parallel connection, the resultant resistance will be like this. So I think all know this. Okay, in series connection, total resultant resistance will be the sum of the resistance at each and every point. When comes to in parallel connection, the resultant resistance will be 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. I think everybody knows this formulas. Okay, so in series connection, current will be same but the voltage will be different. And in a parallel connection, voltage is same but the current will be different. Okay, in series connection, when there is a circuit break, so the current flow will be stopped. But in a parallel connection, when there is a circuit break in one branch, so the current will be flow to other branch. Okay, so components are connected end to end forming a single path for current. So this is series connection. Components are connected across each other forming multiple parts. If it is having multiple parts, that connection is parallel connection. The same current flows through each resistors in the series. The current will be same at each and every point in series connection. The total current is divided among the different stages. Okay, voltage. Just now I have explained. So these are the things which I have already explained. So have a look at this. Next question. What is electricity primarily described as? Flow of protons through a conductor, flow of electric charge, mainly electrons, movement of neutrons in a magnetic field, conversion of light energy into heat. Okay, so students, I have explained all the important concepts in this particular electricity chapter. So now I am displaying the MCQs, so you must mention your answers in the comment section. Okay, even I will explain in these MCQs also. So tell me, students, what is the answer for this question? Yes, very good. Listen, read the question properly. At the beginning of the session itself, I have explained what is electricity. Electricity is nothing but flow of charges, especially electrons. Okay, charges are of two types. Positive charge, which is known as proton, negative charge, which is known as electron. So mostly the flow of charges, especially which type of charges? Electrons. Okay, very good. Which quantity represents the electric pressure that pushes electrons? Current, resistance, voltage, power. Now tell me. Okay, which is the term that pushes the electrons to flow? So tell me. Which term is used for the which pushes the electrons to flow? That means that pushes the charges to flow to generate electricity. That term is considered as, very good, voltage. Okay, very good. Next, according to Ohm's law, if resistance is doubled and voltage remains same, the current will. We all know V is equal to IR. So they are saying that resistance is doubled. That means R is equal to 2R and voltage remains the same. Voltage is nothing but V. So let's and the current will be. From this we can write that I is equal to V by R. So they are saying I is equal to V by 2R. So what is happening here, students? I is equal to half into V by R. That means current is halved. Yes. So even I have explained you. So what they are saying, students, we all know what is Ohm's law. Ohm's law is nothing but voltage induced is equal to the current generated. That means current is always directly proportional to the voltage but inversely proportional to the resistance. From that formula we will get V is equal to IR. They are saying that resistance is doubled and the voltage remains the same. So the current induced will be what? Okay, if you substitute those things in the formula, we will get half V by R. That is nothing but current is going to be halved. Okay. The correct formula for electric power is P is equal to V into R, P is equal to I into R, P is equal to V into I, P is equal to V by I. So tell me students, yeah, what is the answer for this question? What is electric power? I have told you already. The rate of electric energy that is either transferred or converted. The rate of electric energy that is either transferred or converted is known as what? Electric power. So it is measured in either watts or joules per second. Okay. If for smaller quantity the electric power is measured in watts, for larger quantities the electric power is generated in either kilowatts per hour or megawatts. Okay. Yes, P is equal to VI. That means power is equal to voltage into current. Option C. Okay. Next, electrical energy is commercially measured in joules, watts, kilowatts, ampere seconds. Commercially, now tell me students, electrical energy is commercially measured in joules or kilowatts hour. So tell me. P is equal to VI, Katyayani, after a long time. So tell me the answer for this question students. Electric energy, kilowatts hour, very good. Which type of current has a constant direction of electron flow? Alternating current, direct current, pulsating current, sinusoidal current. I have told you already. So we have two types of current. Static current, current electricity. Okay, current electricity again classified into DC, AC. So DC is nothing but the flow of electrons takes place in a single direction. And if the flow of electrons takes place in a bidirectional or in a different direction, we say it as what students? AC current. Now tell me the answer for this question. Very good. Okay. Household electrical outlets typically supply direct current, alternating current, both AC and DC simultaneously, no current. Household electrical outlets. The current which we are using in our household is direct current or alternating current. So tell me students. Each and every students who are in the live session, even if you know the answer or not, you must mention your answer in the comment section. Very good. Alternating current. Okay. The current which we are using in our daily life is alternating current. Okay. If the power is gone, we will switch on the inverter. So what is happening in the inverter? Direct current is converting into alternating current. Okay. In a series connection, voltage is the same across each component, current is the same through each component, total resistance is less than the smallest individual resistance. If one component fails, other continues to work. So tell me, I have told you already what is series connection, what is parallel connection. The series connection, okay, it should not be, so they are saying that must not be either in a same manner. If the negative charge is connected to the positive charge and if the positive charge is connected to the negative charge, series of cells gives us battery. Okay. If the series is following either in different directions also, that is considered as series connection. In series connection, the current at each and every point is same. If there is a circuit break at one point, so there will be a stoppage of current. Okay. The current is same through each component. Which statement is true for parallel circuits? Total current is same as the branch current. voltage is divided among the branches. If one branch breaks, the other branch can still function. Equivalent resistance is higher than the highest individual resistance. So tell me students, I have told you already, in series connection, current is same through each and every point. Current is same through each and every point. So if a circuit breaks, then the flow of charges will be stopped. But in a parallel connection, it is made up of two branches. If there is a break in one branch, okay, the current will flow in another branch. Okay, now tell me the answer. Very good. If one branch breaks, other branch can still function. Electromotive force is best described as always equal to terminal voltage, the potential difference when current is flowing, the maximum potential difference when no current flows, measured only in AC current. So I have told you what is the difference between voltage and EMF students. Voltage is nothing but EMF minus internal resistance. Okay. Now tell me, when there is a maximum potential difference, okay, when there is a maximum potential difference when no current passes, so what we will say that as? We will say that as EMF. EMF is nothing but the energy required, the energy supplied from a source to an object, okay, when there is a maximum potential difference when no current flows is considered as EMF. Okay, the maximum potential difference when no current flows. The heating effect of electric current is also known as Petlier effect, Joule heating, Seebeck effect, Faraday effect. Heating effect is nothing but when electric energy is converted into heat energy. I have even explained you with example also. Examples, toasters, fuse. So what is happening in the fuse, students? Actually the electric energy. When the voltage is high, the material gets melted and the circuit will be break, so that there is no passage of current. Okay? Joule heating. The correct formula for heat produced due to current in a conductor is H is equal to I square RT, H is equal to VIT, H is equal to IRT, both A and B. So tell me the answer for this question, students. Yeah, now tell me the answer. So we all know V is equal to IR, right? Okay, that means, now tell me the answer. No. So if you look at option B, that is also correct. Why? Because in the place of V, if we apply IR, so H is equal to I square RT. That means both A and B. Option D is the correct answer. Yes, very good. Okay. If you get a question, first look at the options, students. If there is any options like both A and B, so you must check again and again. Okay? Which material is commonly used in fuse wires because of its low melting points? Copper, tungsten, alloy with low melting point, nichrome. In order to break the current passage, the fuse must be made up of which type of material? Tell me, students. What is very good, Vamshi? Very good. The alloy must consist of a very low melting point. Why? Because when there is a high voltage occurs, so eventually what happens? Heat will be generated. Through that heat, that fuse must be melted. Okay? Then only the electricity flow will be stopped. Incandescent bulbs produce light mainly due to fluorescence, incandescence heating of filament, phosphorescence, chemiluminescence. So tell me, students. And the answer for this question is also B. Very good. Okay. Next. A device that converts mechanical energy into electrical energy is inverter, transducer, generator, rectifier. Tell me, students. I have already told you. What do you mean by inverter, students? Inverter is nothing but DC to AC. Okay. Transducer is one form of energy to another form of energy. And rectifier means AC to DC. Now tell me the answer. Very good, generator. Okay? Very good. Varshini, Chintala, Vamshi, very good. Transducer is nothing but it is converting one form of energy to another form. That may be either heat energy or mechanical energy or some other energy. Okay? And inverter is used to convert AC to DC, DC to AC, mechanical to electrical, heat to electrical. Inverter, okay, when the power is off, so what we will do, students, the current is converting from DC to AC. That means already the current which is stored in the batteries, that is direct current, it is converting into AC, DC to AC. Which of the following is an input transducer? Sensor, loudspeaker, electric motor, microphone, heater coil. I have already explained you what is transducer, students. Transducer is nothing but it is a device which is converting from one form of energy to another form of energy. Here we have two types of transducer. One is input transducer, example sensor, and other is output transducer, example actuator. What is happening in the input transducer, students? Sound waves are converting into electrical signals. Okay, sound waves are converting into electric signals. When comes to output transducer, electrical signals are converting into sound waves. Now tell me the answer. Microphone, very good. Okay, and the loudspeaker is output transducer. In loudspeaker, what is happening? Electrical signals is converting into sound waves. Which of the following pairs is incorrectly matched? Series circuit, same current through all the components. Parallel circuit, total resistance higher than individual. AC current, direction remains constant. Ohm's law V is equal to IR. So, identify the incorrect pair and mention your answer in the comment section. Very good. AC current. Why? Because in AC current, the direction remains different. Okay, in AC current, at each and every point the direction differs. Which of the following is the incorrectly matched pair regarding resistor connection? Series, current same, voltage adds up. Parallel, voltage same, current divides. Series, if one fails, entire circuit breaks. Parallel, total resistance is sum of individuals. So tell me, students. So what is the answer for this question? Incorrectly matched. Yes, option D. Why it is D? Tell me, students. Total resistance is sum of individual that happens in the series connection. Okay? Not C. So C is correct. Why? Because if one circuit breaks, the whole current will be stopped. Next. Which of the following is not an application of the heating effect of electric heater? Electric iron, toaster, loudspeaker, fuse. Now tell me the answer for this question. What is the answer for this question? I have already told you heating effect or Joule's law of heating is nothing but what is happening here? Electrical energy is converting into heat energy. Among the four options, one is not the example for that. So what is that? Okay? Option? No. Fuse is also an example for, very good, loudspeaker. Why? Because loudspeaker is a output transducer. What is happening in the loudspeaker? Electrical signals are converting into sound waves. SSC GD special batch complete course is available on Chandan Loix app. SSC CGL complete course is also available. RRB NTPC special batch complete course is also available on our Chandan Loix app. SSC exam complete course is also available. Railway exam complete course is also available on our Chandan Loix app. Bank exam complete course is also available. Bank SSC RRB combo course is also available. APPSC TGPSC SA constable courses are also available. UPSC CSAT complete course is also available. So each and every course we have classes both in English as well as Telugu languages. Okay, so like we have 3 channels: Chandan Loix Telugu, Chandan Loix English, and Chandan Loix main channel. All of you please subscribe to those 3 channels so that whenever there is a live session you will get a notification. Okay, that's all for today. Let's meet in the evening session. Chandan Loix Telugu YouTube channel, Indian history. Okay, like a freedom struggle. Okay, the unit which I am going to discuss in the evening session is freedom struggle. Okay, bye students, take care.